So today we'll talk about lasers explained. So the topic is lasers. So laser stands for light amplification, stimulated emission, radiation. Let's make the cover black so it's easier to explain. So laser is only pointed in one place, like here. So it can only be pointed in here. So it is saying it's cohesive, and that's another way. So cohesive means that in this case two waves are in sync. So they have the same trough and crest at the same point, and also their amplifications end up. So this is the amplification, okay? So the amplification adds up. So with adding up, it just becomes one focus spot. Okay? Also, it needs to have the same line width or direction it's going in. Okay? So that has to be the same. So it has to be same one line width. Okay? So now, stimulated emission. So in laser, this is stimulated emission. Okay? But the other phenomena that are happening are spontaneous emission, and stimulated absorption. So there's two things you need to understand. So that these two are theoretical part, and this also as well as theoretical, but these are three different phenomena. So stimulated emission. So I'm learning to tell you this is the topic. Okay, so now this is stimulated emission. So stimulated emission is when so first you need to know that when a photon comes, electrons get energy because electrons want to get out of the ground state because the ground state is where they have to do more energy. But if they go to the excited state, they have to do less work. Okay, so when a photon comes, they get energy to move. So stimulated emission is this. So stimulated emission. So first let me change this to white. So let's say electron will drop from the excited state since it will run out of energy in 100 nanoseconds. That's very quick. But let's say when it's falling down and a photon comes, well, with that the photon becomes 2 photons. Okay, so that's stimulated emission. Okay, spontaneous emission. So spontaneous emission is when here. So I told you that the electron drops at 100 nanoseconds. Well, that happens because of vacuum events. Vacuum events make it go down that quick. So spontaneous emission happens on its own. Stimulated emission, stimulated absorption happen when humans make it. Okay, so let's do last one. Stimulated absorption. Absorption. Or let's just select all. So the stimulated absorption. So when you when you send a photon to make an electron go into the excited state. So to make a so to that to do that, so you have to figure out which energy of which. Okay, so let's say state has energy equal to 1, and excite is energy equal to 5. So photon has to have energy equal to 4. Since if it's too much, the electron will get out of the atom. But if it's too little, the electron will stay there. Okay? So now, let's talk about constructive, and destructive wave. For it to be a constructive wave, the wave have to have same amplification to add up. So they will add up to make this kind of wave. They have to be in sync or be cohesive. For destructive wave, let's say it is, for that it will turn like maybe this. So I don't know, but they will turn into bad application. So those are constructive and destructive. So let's talk about the applied part. So okay, so now you have two mirrors. Okay, in the middle there are atoms. Okay, these are the atoms. So now you have, let's take the atoms that are perpendicular to the mirrors. Which are 90 degrees to the mirror. Okay, so let's take them. So then you send a wave moving to the right, and then a wave going to the left. Okay, with that it will make this standing wave. A standing wave is an illusion. So with that, so that shows a cohesive. So this makes the laser, because this standing wave just goes in one direction. Okay, so this is the applied part of it. Okay, so for more understanding of the phenomenons, let me talk in a ball version. So let's say there is, so for stimulated absorption. So when a ball is on a cliff, let's say, so this is the ball. Okay, when external force is applied, the ball will go down. So like the photon and electron. And then let's say there's a ball, so there's some feather come, it will disturb it and it'll go down. See, that's spontaneous emission. So the vacuum events will make it go down. So now the last one is this stimulated emission. So let's say you apply a force 2 times. One time. So but then you apply it again when it's coming down the cliff. It'll go twice as faster. So now this is